Okay, so let me note down the initial and final conditions of the balloon. So the initial condition, the diameter of the balloon is how much? 1 meter. Okay, so the diameter is 1 meter initially. Final diameter we have to calculate, and how we'll do it. The initial pressure, which is P1, that is 240 kPa. Okay. What else is given? Initial temperature, that is 290 Kelvin, is being given. Anything else? Okay, final pressure is being given. So P2 is equal to 485 kPa. Okay, so these are the parameters which are given, and the important line, as I said to you, it is okay. So important line is being the pressure is proportional to the diameter. Okay, that is the line which is being given. Okay, so we shall try to solve this. Now, since pressure is being proportional to diameter, if I take away the proportionality symbol and I want to equate the pressure to the diameter, I have to incorporate an constant as it, something like C. Yeah. So if I want to take away the proportionality symbol and equate the two constraints, so I have to incorporate a constant in between them. Okay. So can I write it as P is equals to C into D, where C is a constant? Yes or no?
Yes, sir.
Yes, sir.
Okay. So if I could write P is equals to C into D, I can even write similarly P1 is equals to C into D1 and P2 is equals to C into D2. Yes. From thus, what is just C? It is P1 divided by D1. Okay, I guess I know the value of P1 and D1. So P1 is how much? 240 kPa. K in the sense it is kilo, so 10 to the power of 3 pascals divided by 1 meter. So it is 240 into 10 to the power of 3, which is the value of the constant I can say. So C is equals to 240 into 10 to the power of 3. Okay, that is the value of the constant. So once I got the value of the constant, using this correlation, I can find the value of D2 is it. So D2 is equals to what? P2 divided by C. So final pressure, I know it as 485 into 10 to the power of 3, which is kilo, and the value of C I have just calculated. It is 240 into 10 to the power of 3. So the value of D2. Give me the value of D2, guys.
2.02.
Okay, so 2.02 meters. So now I got the value of T2 just by equating the things. If I got the value of T2, I should update it back. So it is 2.02 meters, which is the value of T2 at the final state when the pressure increased to 485 kPa. Now, the next step is I have to go with the calculation of work done. Is it? No. So work done from 1 to 2 in a PdV displacement work is given by integration from 1 to 2 P into dV. Yes? Yes or no?
Yes, sir.
Okay. Now, now I need, since this is a spherical balloon, so this is a spherical balloon like this. So what is the volume of this balloon if the diameter is d?
Pi d cube.
pi d cube? Sure. The volume of, it's a sphere, the volume. What is the volume of a sphere? Volume of a sphere. Yes, guys.
4 by 3 pi r cube.
Okay. Okay, fine. At least you have said something, so let me take it. So 4 by 3 pi r cube. Okay. So from this 4 by 3 pi r is nothing but d by 2, is it? Whole cube. It is 4 by 3 pi into d cube divided by what is 2 cube? 8. So it is 1 times here, 2 times here. So it is pi d cube by 3 to 6. So in terms of diameter, can I take the volume to be pi d cube by 6? Yes?
Yes.
Okay, now, so this is the volume now. Now, what I'll be doing, I will be taking this particular thing here. Okay, so volume is equal to, so pi d cube divided by 6. So volume is equals to pi by 6 d cube. Now, I'll be differentiating on the both sides. So differentiating on both sides. So if you differentiate on both sides, it would be dv is equals to pi by 6, which is constant, d cube, or differentiation of x to the power of n into x to the power of,
N minus 1.
exactly. So d cube is nothing but it is 3 into d square. Am I right? So I can cancel this 1 times and 2 times here. Okay. So dv is equal to what it is? Pi d square by 2. So here it is dd because you are differentiating with respect to d there. Okay. I can take this particular equation as equation number 1. So why have I done this? Why have I done this? So that I can substitute in my PDV work. So pay into the value of dv from 1 is what? It is pi d square by 2 dd. Now I have changed the limits or changed the differentiation v to d now. Okay. Any doubts until now? Any doubts,
No,
guys?
sir. No, sir.
Easy, right? Just to have used the volume expression of the sphere and just differentiated both sides to get to change um, v to d. So that was my intention. That's why I have done it. Fine. Because why I have done it? Because I don't have volume. See here, if in the case in the given data there is no volume, but I have the diameters. So from diameters I can calculate. So that's why I have just changed things to the diameters. Okay. Now this is equals to further. Can I just write P to be where? Here. What is P? P is nothing but C into D, is it? So we'll just take that because all the things will be in diameter so that it will be easy for me to integrate it. So P I can take it as C into D into pi D square divided by 2 into dd. Now entire things are in what you can say in terms of t. So now it is easy for me to differentiate. Okay. Sorry, integrate. Okay. Now I'll just take the constants away. So what are the constants here? Before I start to integrate it. So what are the constants here? Rachan Bandari. Rachan Bhandari. Immediately left. Next, Rohan Pradeep. Rohan Pradeep. Shabat. Rohan Pradeep is also not there.
Sir.
Shabat, so what are the different constants in the above expression so that I can just take away? Yes, Shabat. Pratish Suvarna.
Yes, sir.
So, what are the different constants?
C and pi by 2. C into pi by 2.
Okay, so c into pi by 2, if I take it out, so the multiplication of d into d square is what? D cube?
Yes.
So integration from 1 to 2, it is just d cube dd. Is it right, Pratish?
Yes.
Okay. Numan Nasadi. Numan?
Yes, sir.
Yes, Numan. So how do I integrate d cube?
D cube.
Yeah. So integration of x to the power of n. Okay, I will give you the formula. It is x to the power of n plus 1 divided by n plus 1. Now here it is integration from d to d cube. Now, what will be the integration? Yes, Numan?
D to the power of 2 plus 1.
D to the power of
2 plus 1.
2 plus 1. So here if it is n, it is n plus 1. Here if it is 2, it is 2 plus 1. Here if it is 3, then it is 3 plus 1. So what's your answer?
I don't know exactly.
Okay, fine. Nashad? Nashad. Nashad is also not there. Namita? Namita? Okay. Nartan? Nartan Yasan. Okay. Niharika? Niharika, so what's the integration of d cube? I'm waiting since long time for to get the answer.
The present sir, Nartan.
Where were you, man, when I called you?
Network, sir, network issue. I am in village.
Okay, fine. So yes, it is d to the power of 4 divided by 4. Okay. over the limits 1 to 2. Okay, if I just solve it further, what it would be? It is c into pi by 8, because 2 into 4 is 8. If I just apply the limits directly, it is d2 to the power of 4, d1 to the power of 4. Further, okay, so
You can see
c,
pi by 8.
okay, so c value we already know, so it is 240 into 10 to the power of 3 into pi by 8 into d value of d2 is 2.02 something. Okay, so 2.02 whole to the power of 4 minus 1 to the power of 4. Yes, the value has already been calculated. What's the value? What's the value?
1.41 into 10 power 6.
So 1.41 into 10 power 6, I can just write it as mega joules. Okay, so this was the problem, guys. So such type of problems will be asked in your examination. So kindly take it. Okay. After this, whether it is required. Okay, try this. Try this problem. Meanwhile, I'll be taking the attendance and I'll be asking the answers simultaneously. Okay. If anyone gets the value of the present problem, just give me the values. I'll be noting it down. Okay.
Sir, the previous
Just try
answer.
this. The previous answer is 1.41 megajoules according to Karthik. I have not verified it.
No, sir, I wanted to copy, sir.
Okay, fine. Yes, guys, answer attendance. Abdul Rahman, Abhinav.
Yes, sir.
Okay, Abdul Rahman present. So let me come from the last today. Numan Asadi is there. Next is
Present, sir.
Muhammad Amin. Muhammad Amin. Adarsh B.
Yes, sir.
Okay, Muhammad Amin is also there. Varun Gopalakrishna Shenoy. Next is Rohan Pradeep did not answer. Rachan. Sandesh Shankar Patil. Prajwal Hegde. Nilesh B. Markal. Next, Amit Sangorli. Vigneshwara. Varun SL. Sumant.
Present, sir.
Okay. Next is Saurabha. Sriraj. Shravan Kumar.
Present, sir.
Shetty Tejas.
Present, sir.
Okay. Shetty Sujay. Shetty Sujay. Next is Shashank PC. Shahzad Abdullah.
Present, sir.
Okay. Sagar Sacharya. Okay. Shabit.
Present, sir.
Ranjit. Ramdas.
Present, sir.
Rakshan.
Present, sir.
Prajat.
Present, sir.
Pratish Suvarna.
Present, sir.
Prarthan Jain.
Present, sir.
Next is Omkar. Within charge.
Present, sir.
Nishchit.
Present, sir.
Niharika. Nandish.
Sir, Nartan.
Yes, sir.
Okay. Nathan. Nandish present.
Present, sir, Nartan.
Yes. Namita. Again, Suraj.
Present, sir. Present, sir.
Was. Okay. Was.
Present, sir.
Muhammad Tausif Ali. Muhammad Sihab.
Present, sir.
Next is Fasil.
Present,
Muhammad
sir.
Fasil.
Present, sir.
Okay. M. Karthik.
Present, sir.
Javel.
Present, sir.
Gautam HS.
Yes, sir. Yes, sir.
So when I called your name, you immediately left the meeting, man. What's the reason?
Me, sir.
Yeah, you.
No? No, I
Yes.
left. No, I didn't. Okay, signal problem. I got signal problem, but I don't think you called my name, sir.
I called your name, I guess, man. I do remember that. Okay.
No, sir.
Okay. Gara. Faizan.
Present, sir.
Present, sir.
Gara. Okay. Benoy. Ashwita. Ashwin K.A.
Present, sir.
Anvit. Chandan C. Okay. Mark.
Sir.
Yes. Fahad. Yes, man.
Yes, sir.
Yes,
You didn't
Fahad.
call my name.
Okay, missed yours also. Okay, Marty.
Thank you, sir.
Okay. Next is where else? Okay, Anvit. Amrit.
Present, sir.
So Benoy present.
Next is Akshay.
Present, sir.
Sir, Amit. Sir.
Amit Mark.
Yeah, okay, sir.
Amit
Thank you.
Mark. Muhammad Reza. Yes, Niharika.
Present, sir.
But unless his speaker is not all right, he can't, I mean, he's not able to speak, connect to you.
Who's?
Anvit.
Anvit. Okay. Anvit. Okay, fine. Marked him. Next is Ashanu. Akshay Arkotian. Okay. Adarsh.
Present, sir.
Akshay Kotian is there. Okay. Adarsh.
Present, sir.
Okay. Okay, fine. So that's it for attendance. How many of you have got the answers for this? Is there any change when compared to the previous problem? What's that change? Muhammad Amin? Muhammad Amin.
So did you mark me present, Benoy?
Benoy. Wait a minute. Yes, man, have marked you.
Okay, thank you, sir.
Okay. Yes, Muhammad Amin.
Sir, temperature is not given.
Okay, fine. So does it make a difference? So in the previous problem, have we ever used temperature in solving the problem? Have you ever used it? I guess temperature is just given very much random basis. We nowhere use the temperature. What else? What's the difference? Yes, I mean,
I don't
in
know, sir.
Suraj. Okay, okay. In Suraj.
The-
Just refer the previous problem and this problem. Okay. In
Pressure is
Suraj.
proportional to cube of diameter of the balloon.
Exactly. So in this problem, the pressure is proportional to cube cube of the diameter. In the sense, it is d cube. So in the previous problem, it was pressure proportional to d. Okay, so that's the only difference in this particular problem. Rest all the thing is same, the approach and all. So you can just take P is equals to C times of D cube. P1 is equals to C into D1 cubes. From this you'll get C. Then go for P2 is equals to C times of D2 cube. From this already you know C, so you can calculate the value of D2. Go for the volume, which is D cube pi divided by 6. Differentiate it, then substitute dv in terms of dd and carry on with the derivation. So integration from 1 to 2 p into dv. Okay, so integration from 1 to 2 p is nothing but c times of d cube. Okay, and dv is whatever differentiated thing you have got. So just substitute, integrate it, substitute the value of d1 and d2. That's it. So what's the answers? What is the value of D here? I mean, sorry, let me write the initial and final conditions. So initial data, initial state is 1 and the final state is 2. Okay. So initially it was how much? 0.8 meter. The pressure was 120 into 10 to the power of 3. So all these are initial ones. And the final, you have to find it out and give me the value. So P2 is equals to 425 into 10 to the power of 3. So this is the value of P2. Give me the value of D, guys, D2. What's the value? So here, the pressure is being proportional to cube of the diameter. So pressure is equals to C times of D cube. So from this I can write P1 is equals to C into D1 cube. Okay, so from the C is equals to D1 cube divided by P1. From this we'll get the value of C. Later P2 is equals to C times of D2 cube. Even I can write that. Okay, from this the value of D2 is how much? So D2 is equals to cube the root of P2 divided by C. Anywhere you will be calculating the value of C. So from this we'll be getting the value of D2. Simple.
C is 234.37 into 10 power 3.
Okay, C is the value of C is 234. How much?
0.37 into 10 power 3.
Okay, into 10 power 3. So this is the value given by Karthik. What about others?
Correct, sir.
That's great. So give me the value of D2.
So D2 is 1.22.
Okay, D2 is 1.22. So this is the Sagas value. Just check it. Everyone has to get the same value. 2.35 into 10 to the power of 5. What is that? C. Okay, fine. C is correct, I guess. Most of them have got the same value. Give me the value of D.
Taken the wrong formula. 0.81 into
Habit
So 1.81.
wrong formula. What's wrong? What's wrong was? What's wrong?
Isn't it P1 by D1 cube?
P1 by D. Yes, it is because I was just, yes, it's a wrong thing here. You calculated correct. Okay. So it is P1 divided by D1 cube. You are right. Okay. Next. Is the
So
value
D2 value is 1.81.
1 point? I don't
I
have
got
an answer.
1.8.
Okay, 1.22. Okay, so even Karthik got the same, Sagar got the same.
No, sir.
Shall
I got 1.8.
1.81.
Yes, sir.
Okay, 1.81. Another value.
No, sir.
Just check. How much?
1.218.
Okay, so 1.218 in the sense again it is 1.22. I think Sagar value is more correct. Many people are getting that. Shall I fix on to that? 1.22?
Yes, sir. 1.22 is correct.
Okay, Muvas. So go ahead with the calculation of work. So work done from 1 to 2 is given by integration from 1 to 2 P into dV. So you need dV there. So go with the volume of a sphere, which is given as pi d cube by 6. Differentiate on the both sides. So dV is equals to pi by 6 into 3d square dd. So again, you can cancel this ones and twos here. So it is pi by 2 d square dd, which is the value of dV. So work done from 1 to 2 is equals to integration from 1 to 2. The value of P is nothing but C into D cube here. So be careful. So it is C into D cube here. Okay. Now, and dV you have got it as pi by 2 d square dd. So it is C pi by 2 is common, I guess. I mean constants. So integration from 1 to 2 d cube and d square, it is d to the power of 5 dd. So if you integrate it, so it would be C pi by 2 d2 to the power of 6 minus d1 to the power of 6 divided by 6, I guess, again. Yes, so it's 6 again here. So I can just write it directly. 6 2 so it's 12, so I'll write it 12 here. Just substitute the values and give me the work done.
And 1.3 megajoule.
How much? Yes, Karthik.
21.35 into 10 power 6.
21.53 into 10 to the power of 6 joules. So
35,
you got
35.
okay. So have you got this 1.22 value, Karthik?
Yes, sir. I have not taken that cube, sir. So I got
Okay, fine.
1.81.
Okay. So just check with this value. Everyone else. (186.2 kilojoules).
6.23 into 10 power 3 joules.
Okay, there is one more answer. 186 point, how much? 2. 186.2.
Into 10 power 3 joules. Kilojoules.
Okay, kilojoules. When most of them are getting the same. 186.2 Nashad. Benoy also same thing. 186. Karthik, just check your answer.
Okay, sir. I'm going to do it.
Okay,
Sir, can you scroll the problem a bit down?
sure. And this is one of the favorite questions in Indian engineering services, even in the GATE examinations also. This balloon problem has its own significance. It has been repeated many times in the GATE examinations or in all the competitive examinations. Okay. So, which value was correct? Karthik, I guess it is 186 because many people have got that.
Yes, sir. Right.
Okay. So this one is the correct thing. Okay. 96.2. So that ends your module, guys. Okay. So work and heat has lot and lot of problems in it. If you go on solving it, it is many different problems are there. But I have just concised the things which is required for your examinations and which was asked in your examinations. So only such problems I have just solved it. If offline classes start, so we shall solve still more problems on this. I think this is more than sufficient for you guys. Okay, and so today is day 5th, is it? So within 10th, so 10th I will be giving the due date. You have to submit your notes along with your assignment 1. So in the previous class, I have given one problem from your previous year question paper, and this is the second problem. So just take a screenshot of this problem. Okay, just take the screenshot of this problem. We have to solve this. So two problems. That one is the previous problem which I was just given. If you have not taken it, even I can show you it now so that you can take a screenshot again. Okay, and homogeneous and heterogeneous mixtures. So that is your one theory question. So totally 3 questions for your assignment. Number 1 is the homogeneous and heterogeneous mixtures. What are homogeneous and heterogeneous substances? So that is your first question. Second question is the problem which was stated in the previous class. And the third question is this particular problem which is just shown in the screen. Okay, so these are the 3 questions you need to write an assignment and just submit within 10th. So 2 different requests will be raised in Google Classroom. So everyone need to post their assignments as well as the written notes in that particular thing in your Google Classroom. So thereby, I end the module number 1. So from the next class, we'll be starting module number 2. So any of the modifications required, in the things which was delivered and regarding the pace, and if it has any there.
Oh, sorry, everything's fine.
Everything is fine. Okay.
Also.
Okay. So even the second module is interesting. The first law and second law. We shall start it from the next class. Okay, guys. Take care.
So first I couldn't attend class because I had Infosys test, sir.
Okay. Just put a
I
mail.
have a contact to inform you. So.
Okay, you could have informed me that would be sorted out then
Okay.
itself. Okay, fine. No problem, Saga. So what you do, you just put a mail to me. putting CC of to your class advisor. Class advisor is Ashwini ma'am, I guess. Okay. So just put a CC to her, then I'll mark it. Okay. Okay.